My dear students, after a long time I am here in YouTube again. So this topic is very important for the board examination 2021. The 100% sure in one of the set this question will be definitely asked in CBSE class 12. So the topic is relation between current and the drift velocity. So let us find the relationship between current and the drift velocity. So to find the relationship, let us consider a uniform conductor whose length is L and whose area of cross section is my A, right? And which is connected to this battery. And whenever I switch this on here, then what happens is this will act like a positive and this will act like a negative, because this is connected with the positive and this end is connected with the negative. I am just taking the part of the conductor to derive the relation. So inside this there will be electric field in this direction from positive to negative, and what happens is that what will be the action of this electrons in the presence of electric field? It will experience a force called the Lorentz force, and the direction of force is opposite to the direction of electric field because electrons are negatively charged. Now there will be a net drift of the electrons in this direction opposite to electric field, and this is the drift velocity, right? So the electrons will be drifted from negative to the positive. That is why the direction of actual current is from negative terminal to the positive terminal. Okay, this is the reason why the current is the actual direction of current is from negative to positive, unlike the conventional. So whenever we apply the battery, there is electric field. Because of that, there is net drift of the electron which will result in the flow of current. Okay, so we have to find the drift velocity relation and the current. So we know that the current is I equal to Q divided by T. Let me write this as equation number 1. Our whole purpose here is to find the charge Q and the time T, and we put this value in equation 1, we get the answer. Okay, to understand this concept, let us go to this concept first. So this is my radius R, and what is the area, what is the volume of this cylinder? The volume of this cylinder would be pi R square into L, right? And this can be also written as A into L. Why A into L? Because pi R square is the area of this circle, base circle. Therefore, I can always write A into L is the volume of this one. Okay. Now, if I have this much of volume here, okay, which is my unit volume, okay, and in that unit volume, I have this many of balls like this. So I have 4 balls. Okay, I have 4 balls in unit volume. I will write this here, 4 balls in unit volume. Okay, so similarly what I do here is let N be the number of electrons in unit volume. Okay, let N be the number of electrons in the unit volume. So how many balls are there? 4 balls in the unit volume. How many electrons are there? N number of electron in the unit volume. So which is also called as number density. Okay, so this is also called the number density. Okay, so if I have the whole volume, then this whole volume, then how many numbers of the balls will be there in whole volume? So the total number, okay, total number of balls in entire volume of cylinder, will be how much? In unit volume I have 4. Okay, then if I multiply with the volume of cylinder, then I will get the total number of balls in the entire volume. So therefore here also the total number of electrons in the conductor would be how much? first I have to write total number of electrons in the entire conductor will be how much? See here, number of bulbs into volume of the submerged cylinder. So how many number of electrons are there in unit volume? N. So it will be N into volume. So will be equal to how much? N into what is the volume? A into L, as like that. So A L. So this is the total number of electron present in this conductor. Fine. So let us find the charge, total charge present in this conductor. To find that, let us go to again this example. If it has got 2 kg, ball is 2 kg. How many kgs balls are there? 2 kgs balls are there. Now, what is the weight of that? What is the weight of all the balls? How much will be the weight? Let me write. Weight of all balls equal to how much? It will be 2 is there, 2, because the weight of one ball is 2, then I have to multiply total number of balls, isn't it? 2 is the weight of one ball. If I multiply with the total number of balls, then I will get the weight of the total balls in the cylinder. Similarly, let us find the total charge of the electrons in conductor. As similar to this, how much will be this? Now, this will be Q will be equal to how much will be the total charges? The total charges will be what the value of charge of one electron multiplied by the total number of electron, as like this. So what is the value of charge of electron? Is my E, okay, then into total number of electrons, isn't it? And this will be E into what is the total number of electrons? We will find this as NaL. So we got the value of Q as equation number 2. Okay, now let us find the value of time t. Okay, so to find the time t, let us do one thing here. Let all electrons, okay, passes through the conductor, okay, conductor in time t. Okay, all the electrons have passed this conductor in time t. Okay, so let us find the time. What is the equation of that time? To find the time, what I do here is, we know speed equal to distance by time. Okay, from here I will show you the value of time is, time will be equal to, this is distance, right, and divided by speed. Okay, now as we have already said that this time will be distance upon the speed. Now how much is the distance of the conductor? The distance of the conductor is the length of the conductor, because the electron have to pass through the length. So this will be L divided by what is speed. The electrons are moving with the speed of drift velocity. So I will just write V d over here, and this is equation number 3. Now what I can do is, we can always substitute the equation number 2 and equation number 3 in equation number 1 to get the equation of current and the drift velocity, like this. So substituting the value of Q and T in equation 1, we get this current I is equal to, what is value of Q? It is E N A L divided by VD. Okay, and this L and this L will cancel, and this VD will go up here, right, multiplicative inverse. Then I will get this I is equals to, I will write N here, E A and VD. So this is the relationship between the current and the drift velocity. Okay, so this is the simplest derivation that you can find. Okay, so with this we end this topic, but I am going to put some more definitely coming 100% sure derivations of class 12 in coming lessons. Thank you.